Hello students, welcome to the DC Machines and Transformers Laboratory demonstration videos. This is the second experiment in first cycle. This is load characteristics of DC compound generator in cumulative and differential connections. As usual, in the first experiment we have seen the circuit connections similar to that separately excited here in uh, compound generators. The circuit diagram is to be uh, drawn in your record notebook. Based on the circuit diagram, you have to make connections here with the machine, right? This is self-excited type. Previously in the first experiment we have seen the separately excited type. This one is the self-excited type. Self-excitation meaning that the excitation of field winding for generator is taken from itself. That is, the generator DC voltage is connected with the field winding of the generator itself. So there is no need of separate DC source for excitation. In self-excited, we have different types: series connection, that is series generator; parallel connection, shunt generator; and the compound generator, which has two different field windings, series and is parallel winding. Two different windings are there in a single machine, right? As usual, any generator will require prime mover. Here, the prime mover is a DC shunt motor, and this DC shunt motor is connected with the field control method. Rheostat is there with the field winding, and starter is there to start the uh, DC motor prime mover, and this will give the mechanical input. And it is self-excited. There is no need of excitation from external source. The A1 A2, that is armature voltage, is given back to the field winding itself. So at the starting, it requires some minimum amount of flux to generate a minimum voltage. That flux we call it as residual flux, and the voltage generated with that residual flux is called residual voltage. With that residual small amount of residual voltage, residual flux, it will it will build up the voltage further, and it increases its flux, and so the voltage is built up. So you will get the rated voltage at one point by using the self excitation. Here we are going to do the load test. The load, the resistive load is connected with the generator, right? Yes. Now we are moving to demonstration. Right after making connections, you have to ensure, as usual, you have to ensure things like tightening of the connections and positions of rheostats. Position of rheostat for motor side, field rheostat of motor side should be in minimum, and field rheostat of generator side should be in maximum position, and the switches are open condition. It should be in open condition at initial, and see the ranges of meters that and all available in your cycle diagram, right? So now I'm going to switch on. Switch on as usual. Switch on the DC supply for this table. Yes, switch on. After that, I have to start the prime mover by using the 3-point starter. Gently press inside and gradually moving from this side to that side. So at the end, it is automatically folded. So the motor is running, the prime mover is running, and you have to check the speed of the prime mover. Speed is 1388 now. Actual speed is to be set is 1500, which is the rated speed of this generator or prime mover. That can be done using the field control method. Yes, field control method. I'm doing the speed setup. Yeah, it is 1483. So slightly you have to adjust. So maybe it is 1500 now. So after setting the speed, see that there is some voltage, switch on the load, switch on the load. And you can see there is some small amount of voltage. This voltage is called residual voltage. This is because of the residual flux. With this residual voltage, I'm giving excitation to the field winding, and so it is increasing while adjusting the field current. Voltage is built up. Voltage is built up. We have to give the field current up to the rated voltage. Up to the rated voltage. So the rated voltage here is again 220. So I am applying the field current up to rated voltage. So now my generator is generating 220 volt DC supply, and the respective field current is available here, and this is for measuring the load current. So now I can start loading the generator. So for loading, I have to switch on the main and then first add 2 amp loads so that there is a change in current, change in voltage, all those seems to be noted. So this is to be added another 2 amps, another 2 amps, and so change in current, change in voltage, another 2 amps, and so on. So I have to add the load up to rated current. Here the rated current is 9 ampere as per the nameplate. You can see 9 ampere rated current. So up to rated current, you have to take 5 or 6 readings for different load conditions. What is the voltage and the current, field current, load current and the voltage. So after taking readings, switch off the loads and then switch off the DPSC. Make bring the rheostats to initial position and then switch off the machine. So this may be for cumulative connection in a compound generator. This may be for cumulative connection. This is to be done for differential connection as well. So for that you have to change the polarity of series field winding. This Y1 and Y2 is to be interchanged. Y1 and Y2 is to be interchanged in your connection. After interchanging the y1 y2, repeat the same procedure and take down the readings. That is for differential connection. Previously you have taken for cumulative connection, this one is for differential connection. So that's it. After taking readings, do the calculations and draw the graph and write the inference and result, all those things.